Hello, ladies and gentlemen. Today we are going to take a look at solving literal equations. So this is a part of what we need to be able to do in our linear unit here, being able to practice those solving skills when it applies to a literal equation. You need your notes, something to write with, and a calculator. So our learning target today, or I can statement, is that I can solve a literal equation for a variable. So our job today is going to be to isolate a specified variable given some crazy formula. The first thing I need to get in your notes is what is a literal equation. So when we hear that phrase, literal equation, we're talking about an equation with more than one variable. So a lot of times these are formulas, like in chemistry, the ideal gas law or density formula. In physics, you have kinetic energy. Even in geometry, you had formulas where more than one variable was involved, like the Pythagorean theorem or area of a triangle, for example. So when we talk about solving a literal equation, we're talking about solving for a specified variable within a formula. Now, with your notes today, we're going to need to get 6 examples in there. Here's the first one. Here we have the circumference formula for a circle, and we need to solve it for r. Sometimes you might see these directions worded a little different. It might say in terms of r. That's the same thing as isolating the variable or rearranging the formula for a special variable to be involved or isolated. So make sure that you're aware that sometimes directions might be worded differently, especially in other classes or on the ACT. So here we have the circumference formula, c equals 2 pi r. When it says solve for r or rewrite the formula in terms of r, that means that you're going to get the r by itself. So right now the r is being multiplied by 2 and pi. That's what's happening here, and we need to undo that multiplication so that r is alone. So we would divide by 2 and pi on both sides, and these would cancel out here, and r would be left alone, and on the other side we would have c divided by 2 pi. Notice we don't get an answer like r equals 4. We've just rearranged the formula so that r is isolated, or he is by himself. So all the other variables then are on the other side. Now let's take a look at another one. You've done this before as well. This is y equals 3/4 x plus b. This is a linear equation that we will be graphing later on, but if I want to solve for x, let's first identify where the x is. He's right here with that 3/4. Now notice there's a plus b right here. That's something that we can easily undo using inverse operations. So we can subtract the b from both sides. That would eliminate it over here, giving me 3/4 and the x left. And on this side, y minus b, those aren't alike terms, so I would just leave it as y subtract b. Now on the right side here, I still have 3/4 with my x. Now in order to get rid of the 3/4, I would multiply by the reciprocal. This 3/4 is multiplying by x right now, so I know sometimes we want to divide by the fraction, but it gets a little trickier to simplify on this side if we do that. So I'm going to multiply by the reciprocal of 3/4, which is 4/3, on both sides. Now remember, I got to multiply this whole expression here by 4/3. This side, 4/3 and 3/4, would multiply to make 12/12, which would make 1, so it's 1x. And here I need to distribute 4/3 to both of those terms, giving me 4/3 y minus 4/3 b. This is the new expression or equation in this case where x is isolated or alone. So we undo everything we see with that x or near that x to try to get him by himself. Now here's another one. Let's solve this one for y. So y is right here, and to get y by himself, first of all, I'm noticing there's an 8x being added to the term that includes y, so I'm going to get rid of that 8x first. So I'm going to subtract 8x from both sides, giving me 3y equals, on this side you can have 48 minus 8x, but notice that the 48 does not have an x with him, so they're not like terms, so I can just leave it as 48 minus 8x. Of course, you can also write negative 8x plus 48. That'd be fine as well. Now there's a 3 in front of the y still, so let's go ahead and divide by 3 You have to divide the whole other side by 3. Here we go. 48 divided by 3 is 16. Now 8 divided by 3 isn't that nice, right? So we'll just leave it as 8/3, and you can put the x on top. Oops, or you can also write it as 16 minus 8/3 x, like so. Okay? The x can be just next to the fraction rather than on top of that fraction. All right, let's look at example 4. We're going to solve this crazy formula for r. So here's r. I'm going to notice where r is right away since that's my goal, to get him alone. To get rid of this 2x right here, let's subtract that first. So I'm going to subtract 2x. That would leave me with 2 pi r. That's the circumference formula. And on this side we have p minus 2x. All right, next move would be to get rid of or remove this 2 pi in front of the r, which is my goal. Remember to get the r alone. So let's divide by 2 pi, because right now it says 2 pi times r. So if I divide by 2 pi on both sides, that would leave me with r alone. This side becomes rather tricky. You have the p that's being divided by the 2 pi. And you have a subtract sign, and then the 2x is also being divided by 2 pi. The whole expression over there is being divided by 2 pi. So how does that simplify? P can't be divided by 2 pi because I don't know what p is. Oops, excuse me, here we go. Try not to do that or select that. 2 pi, there we go. And then minus, and over here you do have a 2 over 2, see that? Here you'd have x over pi when we simplify that, okay? So the simplifying is really what kind of gets tricky when we go ahead and solve these equations for specified variables. Now let's try number 5. We're going to solve this one for a. And oh no, look at it starts with a fraction. Oh dear. We're going to be fine. Here we go. We have an a in there. There he is. That's our goal, is to try to get that a by himself. So the first thing I would do, see how this whole expression here is being divided by 12? Let's get rid of that dividing by 12. How do we do that? We do the inverse. We'd multiply by 12. So I'm going to go ahead and put times 12 on this side and times 12 on this side. Multiplying by 12 and dividing by 12 are inverses, so we would be left with AB plus 8. And on this side we'd have C times 12, which is 12C. Now still a is my goal. Here he is. Let's get rid of this 8 now. Let's go ahead and subtract 8 from both sides. So that's gone, leaving me with AB. And this side becomes 12C subtract 8. Now remember, a is my goal still, and a is being multiplied by b. So I'm going to go ahead and divide by b, and you got to divide both of those by b. So I'd have a equals 12c divided by b. That doesn't simplify. Ooh, I don't know why that's making a funny line there. And then minus 8 divided by b. There we go. This is my simplified answer. So 12c divided by b minus 8 divided by b. All right, here's our last one. Example 6. We're going to solve this one for p. Now with this one, there's a little bit of something strange happening. Do you see this? The variable we're trying to isolate is in 2 different spots. So sometimes we would say, well, which one am I supposed to get alone? The answer is both of them at the same time. They're the same variable. So this one's going to be a little bit trickier for us to kind of maneuver through this. But the first thing I would do, noticing that the p's are in both of these terms, I would add this t over. He doesn't have anything to do with these terms that include p. So let's go ahead and add t to both sides. So on this side we get r plus t, and here we have pt plus ps. And now remembering that we're trying to get p by itself, noticing that p is in 2 locations here, remember when you learned how to factor something out of an expression? What we're talking about here is p is in both locations, so we're going to factor out a p from both terms. Factor means to divide it out. So we're going to go ahead and write p because we're dividing out or factoring out that part of those terms. And when I divide out a p from this first term, I'd just be left with the t. And when I divide out a p from this second term, I'd just be left with the s. So I'd have the p factored out, and then we'd have t plus s in parentheses. That is a factoring process, okay? That you learned in Algebra 1. Ooh, I don't know why those funny lines are popping up. Okay, that is factoring. So on the other side, though, we still have r plus t, no big deal. So now we need to go ahead and try to get the p alone. The good news is by factoring, we made one p happen, right, in one location. And this p is being multiplied by this whole expression here, the t plus s business. P is being multiplied by t plus s, so we can undo that by dividing by t plus s. Okay? And I'm going to do that on the other side, like so. This side would be just left with p, and now be careful. Yes, you're thinking I got t on the top and the bottom, I should be able to simplify that. Not true. When these are joined by addition, guys, you can't just cross off one piece there. Okay, we got to be careful to leave these factors together. So this is the way my final answer would look with p all by himself or isolated. Okay, so our job today is to get those variables by themselves and make sure that we understand inverse operations and how to work with those to rearrange these formulas. I want to thank you everybody for taking good notes. Kincaid out.